All right, this section we're going to go into problems that involve centroids, altitudes, perpendicular bisectors, maybe some distances, medians. And I'm going to start with this one, which is probably it's one of the hardest. Find the equation of a circle that goes around a triangle with these vertices. I have another video on this because this was on test 3.2, so you can go look for this video. And it does it's the exact same problem with different points, finding the equation of a circle. Also, here's some note sheets. I'll put these in the link to the notes in the description. But here's just kind of a visual definition of what a perpendicular bisector is. It goes through the midpoint and it's perpendicular to the base. And this is how you generate circumcenters. If you find two perpendicular bisectors, they intersect at the circumcenter. Two perpendicular bisectors, they intersect at the circumcenter. Medians go through the midpoint and the vertex, and to find the equation of that line, you use those 2 points. So you'll get the slope by doing y2 minus y1 over x2 minus x1. That'll give you the slope of that line. And then you need one more point on the line. You can either use the vertex or the midpoint to get the equation of the line. Altitudes, they go through the vertex and they're perpendicular to the base. So if you need to generate the actual equation for that line, like mx plus b, you'll start by getting the slope of this line from the 2 points, doing the negative reciprocal to get the perpendicular slope, and then plugging in the point, which is the vertex. That'll get you the equation of that line. Let's see, and the altitudes, intersection of the altitudes generates the orthocenter. The medians generates the centroid. In center, you guys didn't do, you can ignore that. We'll come back to that one. All right, for us, we want the circumcenter in our problem to generate the equation of a circle that goes around these 3 points. So we're going to have to find two perpendicular bisectors. All right, let's get to work. So at first I'm going to make a rough sketch of my triangle, and then I'll decide which two perpendicular bisectors I'm going to get. So I have 3 choices. I think I'm going to choose this one, which will be approximately like that. And I like this one. So my perpendicular bisector, or my circumcenter, should be in that vicinity. I'll use my graph to check my answers and make sure they seem reasonable after I'm done. Okay, my process is I need to find the equation of these 2 lines and then get their intersection. That'll be my circumcenter. So to get an equation of one of these lines, I need a slope and a point. The slope of this line will be perpendicular to the slope of this line, and it will go through the midpoint. So I've got some work to do. I need to calculate the slope, then the perpendicular slope, and then I also need to calculate this point. To get this slope, I can do y2 minus y1, or I can just count it out, which is easier. So see, the rise is down 1, 2, 3, 4, so it's -4. And the run is 1, 2, 3, 4, 5. Slope of this line is -4 over 5. Therefore, the slope of this line is +5 over 4. Now I need to calculate this point. A midpoint is the average of the x's and the average of the y's. So the average of -3 and 2, I'll write that out. Oh, that's a fraction, how terrible. So it's -1/2 for the x coordinate. Let's see the average of the y's. I guess something's wrong there. This must be a -2. So 2 plus -2 over 2 is 0. I guess that seems reasonable. That looks visually reasonable. All right, so I can either use point slope or mx plus b. I'm going to use mx plus b. And then I'll plug in my points. So that's -5/8, but I'll move it to the other side. It'll become +5/8. So this equation is 5/4 x plus 5/8. Pretty terrible that it has fractions. Maybe it's a good time to mention that you can get TI-84 calculator programs that will calculate the circumcenter based on these 3 points. To do that, you can just Google circumcenter triangle, something like that, and you'll probably find some video and then look for the link to the program. Yeah, so actually search TI-84 circumcenter triangle program, something like that. And then you also have to find out how to put that on your calculator, which requires the TI Connect software. So you'll have to Google that too. All right, let's continue. We've got our first perpendicular bisector. And to get the second one, we'll just repeat the process. Slope of this line, let's see, it's down 3 and left 4. So the slope of this line is down 3 and left 4. The rise is -3 and the run is -4. So therefore it's +3/4, which seems reasonable. And then the perpendicular would be the negative reciprocal of that, -4/3. So slope of this line is -4/3. Now I need the midpoint. It's the average of the x's. So -2/2 is -1. And the average of the y's, 2 plus 5/2, 7/2, another fraction. I'm going to turn it into a decimal. So I've got a slope and a point. Then I'll plug in my point. Let's see, so that goes away. So I'll just subtract 4/3. I'd probably use my calculator for this. All right, I could have gone with decimals, but I went with fractions, but for no good reason. Decimals would have been fine. So I'd convert that back into a fraction, 7/2, and then move to the 4/3 over. So I did a common denominator. I have to multiply this one by 3 and 3, this one by 2 and 2. And it turns into 13/6, which I estimate this, and that looks about right. Check this one. Y-intercept of 5/8. Yeah, it looks about right. So pretty confident in that equation. All right, I got 13/6. So let me just plug that back in for B, and this is the equation of the other altitude. Okay, it's winding down now. Now I've got my 2 equations. It's time to find the intersection, which requires substitution. And I guess this is kind of a long problem to put on your test, so hopefully you won't have one like this. And if it is in multiple choice form, maybe you could just graph it and like eyeball the answer and pick the right answer from the multiple choice. Hopefully you don't have to do this on this test. All right, so I'll do substitution. I'm just going to set them equal to each other. 4/3 x. Ugh, and look at all these dirty, rotten fractions coming up. So I might cave and just turn these all into decimals. Because even just getting common denominator is really a pain in the butt. All right, I think I'm going to tough it out with the fractions. So I'm going to multiply by 24 because I can see all these numbers divide into 24. So this should kill off all these fractions. So you could punch these in your calculator, or you could just turn it all into decimals. It's probably what you should do. All right, but I'm an idiot, so I'm going to stick with fractions. So that's negative 32x, and multiply by that. The 6 reduces to 4. E because just 4 times 13, 52. 24 times that, we're left with 6. And I'm not explaining what I'm doing there, but 24 times this one, the 8 cancels and 3 is left over, so plus 15. All right, eek, this is just terrible. So I just added 32x to both sides, and then subtract 15, eek. Really should have gone with decimals. All right, but let me just spot check that. And yeah, I guess that seems reasonable. That's a little more than a half for my x coordinate. Wonder if I did something wrong. It seems suspicious that I got such terrible fractions. All right, but then to get the y coordinate, I have to plug this back in to one of the equations. So I'll just choose this one. And I just punch that into my cool calculator that does fractions for me. So 85 over 62, which is, let's see, bigger than 1 but less than 2. Let me see if that makes sense. Yeah, that seems about right. So my circumcenter is 37 60 seconds, comma 85 60 seconds. And now it's time for the equation of the circle that goes around there. The general form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. Where h and k is the center and r is the radius. So I've got the center, but I need to calculate the radius, which will be a distance from this point to any one of these other points. The distance formula, it's x2 minus x1. I'll write it. Squared. Probably I'm just gonna have to quit with these fractions. This is definitely too far. It's gonna be, well, I'll stick with it. All right, and then minus 5. All right, I had to give up on this fraction. So for this distance, I got 3.65136, etc. All right, last step, I'm going to turn that into the equation. Let's see, I'll write it up here. So x minus 37 over 62 squared plus y minus 85 over 62 equals 3.65 squared. So I'll just go ahead and square that. Instead of writing 3.65 squared, I'll just punch in the calculator. Squared 13.33. Yeah, I should just eyeball that distance, 3.65. It seems about right. My center seems about right. So that's it. It is super suspicious, these weird fractions. Usually if they give you a question like this, it wouldn't be that terrible of a fraction. But hopefully I didn't make some little mistake through all this process. But I am trying to rush. So sorry if you find some mistake. Let me know, please, if you do find one. Problem number 27 is asking something about perpendicular AB It's hard to figure out what they're even asking though. Let me at least graph these points A, B, C, and they're talking about a segment AB, and they're talking about some line CP, but they don't really tell us where P is. Write an equation. Okay, so that's gonna be like some y equals mx plus b thing, I think, that describes a set of points P, okay, for which AB is perpendicular to CP. So let me check that out. The only way CP can be perpendicular to AB is if it's something like this. So I'll just put CP, I'll just eyeball it like right there maybe. Yeah, that would be perpendicular-ish. But maybe P could also be right there, maybe, something like that. Let's start off with just getting the slope of this line and then the perpendicular. All right, I could do y2 minus y1, but I'm just going to count it out. To go from A to B, let's see, the rise is 1, 2, 3, and the run is 1, 2, 3, 4, 5, 6, 7, 8. Let me check my signs. Yeah, it's up 3, so positive, and it's right 8. Therefore, the slope of this line is the negative reciprocal, negative 8 over 3. Seems right, down 8 over 3. And now I want the equation of this line. So I have a point and I have a slope. So y equals negative 8 over 3 x plus b. And this point is 2, negative 3. So I'll plug in that point, solve for b. I've got some fractions to deal with here, but let's see, I plugged in 2. This is not 16 over 6, by the way. You just multiply the top. If it helps, you can put it over 1. Top, top, bottom, bottom. Negative 16 over 3. Add that to both sides. I'm going to switch this to a denominator of 3. So it becomes negative 9 over 3. Plus 16 over 3. Negative 9 plus 16. 7 over 3 is my b. And I just eyeball that. Yeah, that's a little bigger than 2. It's about like right there, which seems reasonable. I'll just put that back into my equation. All right, so as long as P is anywhere on this line, it could be there, it could be there, it could be there, then CP will be a perpendicular to AB. So write an equation that describes where P could be, all points P. That's our answer. I guess if it's multiple choice, it'll be choices like this: A, B, and this one will be -1. If it's multiple choice, hopefully, I mean, you probably just graph these points, get a picture, and then maybe just graph some of the lines and just see which one seems reasonable. Like maybe this line would look like something like that. Which, yeah, can't really determine if that's reasonable or not. It looks kind of reasonable. See, -1, go over 1. But I guess if I graphed it more accurately, I could see it doesn't even go through C, so I could cancel that one if I got some other line that said y equals 5x plus 10. That'd be way up here, so I can see that's not perpendicular. So yeah, just keep in mind that multiple choice questions might give you some opportunity to shortcut the problem. 35 is talking about medians, perpendicular bisectors, altitudes of mid-segments, and angle bisectors. So we'll recap on these. Which of these must go through the vertices of a triangle? So let's see. Medians does have to go through a vertice. Perpendicular bisectors do not. But they could if it's a isosceles triangle, it will. Altitudes definitely do have to go through vertice. Mid-segment. Let's see, what are they talking about? Mid-segment. I gotta think about what they mean by that. Angle bisectors, which I don't think you guys even had that in class. That looks like this. That does go through a vertice. Okay, a mid-segment. I don't think you guys had that either. That definitely is a typical geometry thing you learn in a normal geometry class, but a mid-segment is like that. Goes to the midpoints. So that does not go through the vertex ever. Is it possible for a median to also be an altitude? So here's a median and here's an altitude. And if the triangle is just the right shape, yes, it is possible. So it would have to be isosceles. So now this altitude is also a median, just because it's symmetric left and right. See, the median goes to the vertex and the midpoint, and the altitude goes to the vertex and is perpendicular. It's possible for a mid-segment to be a median. Well, mid-segment looks like that. Doesn't go through a vertex, so there's no way for that to happen. Is it possible for a perpendicular bisector to be an altitude? So for these two things to match. And yeah, for that isosceles triangle. I guess for isosceles, all three of them are the same. All right. 42, it's related to the centroid circumcenter topic because it's got perpendicular bisectors. There's no triangle in this one, there's no circumcenter, but perpendicular bisector, similar idea. Let me graph these points. I don't necessarily need to have a nice graph. You could just have a sloppy graph, 5, -2, or no graph at all if you can just visualize it. I'll make a graph. 10, 7. All right, the perpendicular bisector to this segment should be something like that. And to find it, I will need two things. I'll need a slope, so it'll be perpendicular slope, and I'll need a point, which would be my midpoint. So all perpendicular bisectors go through the midpoint. So the midpoint is the average of the x values and the average of the y values. So the average of 5 and 10, that's a 2. 7.5. The average of -2 and 7 is 2.5, which seems reasonable. I'll just check that. Seems about the right place. The slope of this line, I'll just count it off. The rise is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the run is 1, 2, 3, 4, 5. Rise over run. The perpendicular slope, which is what I want, is the negative reciprocal. So I now have a point and a slope. And I'm going to just choose to use point slope form, where I just plug in the point and the slope, and I don't have to do any extra work. So I'm just going to, I already did this, but I'm just going to check, make sure common mistake is to reverse the x and the y. Yeah, minus and minus. And it is minus. So I'm just check those signs, check that sign. Yep, looks good. This problem might be the worst one yet. Find all the lengths of the medians. So that means I got to calculate 3 medians. Yuck. Maybe it won't be that bad. What is the distance from each vertex to the centroid? So that means I have to find the centroid, which means I do have to find 2 medians. Yeah, this one's terrible. Yeah, there's no way they could give you this on the test. It's just too long. You don't have time to do this problem. All right, let's start by getting the lengths of these medians. The median is from midpoint, at least that one's easy, to vertex. there's one median, then this midpoint, and then that vertex, and then this midpoint, and then that vertex. All right. Terrible. All right, let's just get these midpoints real quick. So that's 2.5 comma negative 1.5. Just taking the average of the x, average of the y's. This one is 2.5 again, makes sense. And negative 1/2. And this one, well, that one I can just read it. It's 0, negative 2. All right, to get the length of these medians, I'm gonna have to do distance formula. So I'll just do this one first. Distance formula is the difference of the x's. So I'll do 5 minus 0 squared. Difference of the y's. So 0 minus 2. I got 25 plus 4 equals root 29. Another one, so it's notice that double negative there, so it's y2 minus y1, so y2 minus 1. I'll just punch that in the calculator. I got root 12.5. So what's that? 3.53. So I'll just eyeball that. I guess that looks okay. It looks a little shorter than 3 to me, so maybe a little suspicious. But close enough, I guess. It's kind of diagonal. Anyway, check that one for mistakes. Seems suspicious. All right, I'm not going to do the third one. So the next part is we have to find the distance from the median to each vertex, which means we need to locate this point. And it seems like we should just be able to eyeball it. But to find the median, we actually have to get the equation of two of these medians and find the intersection. That's a whole big process. To find the equation of this line, you have to get the slope, which is, let's see, it's up 2 over 5. And then you'd have to plug in a point. But I guess I can see the y-intercept is negative 2. So you could plug in that point, but since I already have the y-intercept, I know that's b. And I guess I'll choose this one also since it has an obvious y-intercept. I guess they all do. They all have an obvious y-intercept. Slope of this one, let's see, it's down 0.5. Yuck. It's down, that makes it hard. Down 0.5. And it's to the right 2.5. So I'm trying to just read it from the graph, but maybe this one, if you're not comfortable with that, you just do y2 minus y1 over x2 minus x1. So let's see, so this turns into negative 1/5. My y-intercept is negative 1. All right, zoom out back to what am I trying to do? I'm trying to find the centroid. So I have to set these two equal to each other. Man, no fun. Again, there's calculator programs where you can just give it the 3 points and it will give you the median. Actually, there's a shortcut for the median. Yeah, I think you just take the average of all 3 x values and the average of all 3 y values. I forgot about that. Your teacher most likely didn't tell you about that shortcut, but I will in a second. All right, so I add 1.5x to both sides, so you get 3 over 5x, and then add 2 to both sides. Then I'm going to have to multiply by 5/3. That's the x coordinate. Then I'll have to plug that back in to get the y coordinate. Let's see, that's -1/3 minus 1. So -4/3. Let me just see if that seems reasonable. Yeah, 4/3 down, 5/3 over. Yeah, seems close enough. And it's not over because now I need to find the distance from this point to each of these vertices. So I think I'm going to skip that part. It's just busy work. So the distance formula is x2 minus x1. So I'll do this point. x2 is 0, or x2 is 5 minus x1 squared plus y2 minus y1. Then I'll just punch that in the calculator. And I got 3.6. And I'll just check that. I guess that seems reasonable. All right. Yeah, I'm not going to do the others. There'll be some different distance. But just vertex. So my first one is 3.6. I guess I should have labeled these A, B. This was A, B, C. Maybe I'll call this point X. So maybe I'll say XC equals that. For the other ones, I'd have to say like XA equals XB equals. And let me try that shortcut. I should look it up, but I'm pretty sure the median, it's the average of all 3 x values and the average of all 3 y values. So let's check that out. So average of all 3 x, it's 0 plus 0 plus 5. To find the average of 3 numbers, you divide by 3. And the y value, let's see, it's -1, -3, and 0 divided by 3. So 5/3, and check that out, -4/3. I should have done that. All right, I better hurry up and add that to my note sheet. Centroid. Quick way to solve that. What was I didn't call it centroid. What did I call it? Yeah, sorry, I meant to say centroid there. The centroid is the intersection of all the medians. So let me add that to my cheat sheet. It's x1 plus x2 plus x3 over 3. y1 plus y2 plus y3 over 3. Problem 45, area of a triangle, the one we graphed in problem 43. So it's this guy. So the area of a triangle is, the formula for it is 1/2 base times height. So for a triangle like this, any of the sides could be the base, but the height is going to be not the median and not one of the other sides. I'm going to choose this to be my base, which will make this my height. And luckily those are going to be just nice, easy numbers. I won't have to do any work to get those. So my base is 2, and my height is 1, 2, 3, 4, 5. So I can just plug that in. 2 times 5. So area equals 5. I might count some of these squares and kind of estimate it. 1, 2, 3, 4, something like that, 5. Yeah, it looks reasonable, I guess. And then it mentioned another method using the box method. So the box method says that you draw a box like this that contains the triangles. And then you're going to calculate the area of the box, which is 3 times 5. Oh, yeah, 3 times 5 is 15. And then you're going to subtract these areas. Let's see, the area of this triangle is 3 times 5 times 1/2. And the area of this triangle is 1 times 5 times 1/2. So 5 halves. 15 halves. Okay, so we've got 15 for the box, take away 15 halves for this triangle, take away another 5 halves for that triangle. Let's see, 15 minus 20 halves is 15 minus 10, which is 5.